I'm going to go ahead and take this time to go ahead and go over the two types of forms of graphing parabolas, also known as quadratic functions. The first one we're going to focus on is vertex form. I know it's in vertex form when I have a parentheses squared. That is a good indication that it's in vertex form. While standard form will be in your ax squared plus bx plus c. So just looking at these two, comparing and contrasting them, you can pretty much tell which one's in vertex form because you have the parentheses squared, while here you will have no parentheses whatsoever. So looking at this vertex form, your vertex is the first thing you want to name every single time. Okay? And in vertex form, it is staring at you like a sore thumb. This guy right here is my H, also known as my X coordinate of my vertex. This guy right here is my K, also known as my Y coordinate. There is one thing that you really need to remember, that this guy right here is a liar. Okay, so my vertex is going to be 2, -6. This guy right here tells the truth. So once you have your vertex, you are smooth sailing. In the middle of your T-chart, this guy right here is always your vertex. So that order pair that you just found, put that right here in the center of your T-chart. Then work your way up and work your way down. Now I'm going to show you a little trick in your calculator. So we're going to plug in 1 first. So literally really write exactly what it says. 2, parentheses. We're going to plug in 3, and for x, so 3 minus 2 squared minus 6. Press enter. We get -4. Now remember, parabolas are symmetrical. So if that's -4, this is also -4. Now we're going to plug in 4. Here's when I'm going to show you that trick. Come back up, arrow up to what you started with, press enter. It will copy and paste literally that equation. Then go over to the 3, which is what we're going to change with a 4 now. Press enter. We get a 2. What is there will also be down here because we're symmetrical. Let's do a 5 now. Come back up. Highlight it. Copies and paste it. Now take the left arrow, go over until you're highlighting the 4, which is what we want to change. This time a 5. Press enter. So we end up with 12. Now that we have all our and take the time and plot them. We have 2, -6. 3, -4. And 1, -4. 0, 2. And 4, 2. And then the next one takes us off of our graph. So go ahead and draw a smooth curve. Going through your points. Now our domain for quadratic functions will always be all real numbers, also known as -infinity to positive infinity. Because every x value spit out an answer. Now, range is a whole different story. Range are our y values. There is a lowest point. The lowest point is right here. Okay? Our lowest point. There's nothing beyond that, below that point. So when naming our range, we're going to literally say our lowest y value, which is our vertex, -6. And does it keep? And it keeps on going all the way up to positive infinity. So there is a rule that you can use for our range. Remember, this is true for all parabolas. While range, here's the rule. If it's positive, which it was here, if the a is positive, the rule is k, comma, positive infinity. So if our leading coefficient is positive, if our leading coefficient is negative, which means our parabola will be going down, our rule is negative infinity to k. I hope that helped.